And one way I think about carbon awareness is actually I'm building software which responds to natural cycles of the earth, and it connects me with nature in an indirect way, but it's one of the few ways you can connect with nature, I think, in software. Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Asim Hussain. Welcome to the Environment Variables podcast. We have an exciting episode today talking about carbon-aware computing.
So I'm Scott Chamberlin. I was previously at Microsoft leading some of the sustainability efforts in the Windows organization. And the day this podcast is airing, I'm actually starting a new role at Intel leading their software sustainability efforts.
And I'm Henry Richardson with Watttime. We're a nonprofit really focused on making grid emissions available to partners to achieve impact through load flexibility, siting of renewables. And so we're really excited about the kind of expansion of capabilities in software to take advantage of flexibility in grid emission signals.
Henry, because this is your bread and butter, this is your space. Do you think you can give a go at trying to explain, carbon intensity and these concepts to, the audience here?
Absolutely. One of the things that we spend a lot of time thinking about is how clean or dirty the electric grid is. And what we mean by that is when you make a change on the electric grid by increasing or decreasing load, how does emissions change? So if you decide to schedule a compute load at a specific hour, a certain set of power plants will be responding to that change in load, and they'll have an associated emissions. And so you can see how by scheduling Windows updates to specific times, you could actually affect which power plants are operating. Ideally, we would be scheduling those to when there's excess solar or excess wind, which can happen pretty often in the Great Plains. There's a lot of excess wind, a lot of excess solar in California. But you can also, pick between coal and natural gas if you can have that flexibility. So we measure the intensity of the electric grid, and then we make that information available to software. And making it available to software is what we consider carbon awareness. So can this software take advantage of the time-varying emissions intensity of the electric grid and actually change when it trains machine learning loads, as Scott was saying, updates major pieces of software? Can you run jobs at different times because they're run chronically or regularly? Things like that. So we see lots of opportunities in software to be kind of carbon aware and take advantage of this flexibility.
Yeah, I think there's lots of other examples. I mean, there's other big examples as well from other organizations about where they started to apply the ideas related to carbon awareness. I think broadly, if you have the kind of software workload which can respond to a signal, not all software can. That's a challenge. Not all software can respond like this. But if you do have the kind of workload that can respond like this, and that's why the Windows update is such a perfect type of workload, because it's something that you need to do at some point, but you can have a reasonable amount of flexibility over when that happens. If I'm visiting a web page, I don't have that. I need that web page within 3 seconds. The other kind of famous use case I've seen is, or the large scale implementation of this I've seen is the work that Google's done with their carbon aware data centers, which I think is quite an interesting. Like the work that Microsoft's done with the Windows is on a device level. And Scott, you've told me before, I keep on saying, I'm sure I get the number wrong. Is it 10 billion devices around the world use Windows? What is it?
I think the last public number is either 1.4 or 1.5 billion devices use Windows. 1.5 billion client devices use Windows. And then there's a separate stat for servers and data centers.
Wow. So there's quite a few people in the world who now think it's 10 billion because I just threw that stat out so many times in the past. One of the things you were involved with at your time at Microsoft, Scott, was, Windows, but specifically an announcement that Windows made recently. Do you want to give a quick summary as to what that was?
Sure, totally. And again, this is in partnership with Watttime and Henry's organization, as well as in partnership with Electricity Map and the Tomorrow organization. One of the first things that we did in Windows was figure out how do we bring carbon awareness into the operating system, right? The operating system is responsible for scheduling tasks, one of the things it does. And the question we had was, if we had a CO2 intensity signal, could we, number one, change the behavior of the operating system in a way that was beneficial for the environment and had minimal user impact? And number two, would that have a significant impact in the emissions associated with the energy used by PCs around the world? It was a PC-focused thing, not necessarily a server or a data center-focused thing. So yeah, recently in preview, Microsoft released the first implementation of a carbon-aware scheduling for Windows Update. And so Windows Update is essentially how Windows applies new features for users. And there's a whole set of criteria which go into when is the optimal time to apply an update for a couple reasons. Number one, in a lot of cases, it causes a reboot to happen on your machine, not all cases. And in some other cases, it requires CPU cycles, requires a bunch of things to happen, apps to close, that kind of stuff. So we added to that list of criteria carbon awareness. And so if we can, within a certain time frame, find a period of the day where we think that the CO2 intensity in the grid is going to be lower, we're going to try to do the update during that time rather than at a time of day which might be optimal from the other criteria point of view, but might have higher CO2 intensity. So that's the feature that's just been released to Windows Preview, and in an upcoming version of Windows 11 is available to Windows insiders, not available to the general Windows population yet, and they're doing evaluation and testing of that feature at this point. There's the ability to shift across the time of day, which we would call time shifting, and then there's the ability to shift appropriate workloads to the place where it's being run, and that's what we would call location shifting, right? And there's two, I think, critical challenges with each, right? In time shifting, you have to have some ability to be able to move the load to a different period of time. And that's where you were kind of referring, Asim, is like, hey, when I'm visiting a web page, I can't really move the processing of that visit to a different time of day. So you have to be able to sometimes predict when that is, because you have to, a lot of times you're always scheduling into the future, but you don't always have a long period of time to look forward and wait for a real-time signal. So sometimes you have to prep your workload and predict when that is. And so there's some interesting ML and AI stuff that Watttime invests in to predict when that period would be, so you can get ready, your load can get ready and do it at that time. And that's one thing that is really important for time shifting. Now, location shifting, it also has to be appropriate workload, but in a different sense. Many compute workloads require huge amounts of data to be able to read in, and data shifting is really hard. It's actually probably it's something that would block a really large scale location shifting implementation if you had a large data dependency on that. So things like training machine learning algorithms are pretty hard to location shift if you're not already geo-distributing your data to multiple data centers around the world. And many people are, I'm sure Google in a lot of senses geo-distributing their data to many data centers around the world. And then they could, I don't know what they're doing. They could shift their processing to those, regional locations which had lower carbon intensity at the appropriate period of time, and, say, follow the sun or follow the wind around the world, as long as the data was already there.
And that doesn't speak to the political challenges of shifting data, which is like you might have different jurisdictions, like EU has specific rules and won't let the data outside their boundaries. So yeah, there are not only technical challenges, but also geopolitical challenges, I would say.
Totally correct, Henry. Yep.
Every time you try and have this conversation with anybody about locational spatial shifting, that's the the word data sovereignty just comes up almost immediately in the conversation, and it's challenging. But then again, like within large countries like the United States, there is still a lot of variability between East Coast and West Coast. And I believe the United States is one data sovereignty region. And the same thing is it not? Oh, he's shaking your head, Scott. No.
A lot of the data sovereignty laws, the privacy laws are being written by the states today. And so say Illinois has a really strong one, California has a really strong one. So again, it depends on the nature of the data, whether it actually falls within that data sovereignty law. Not all data is going to. There's a lot of data that's just generic and is not tied to individual privacy stuff. And so that certainly wouldn't apply. But when you're doing, machine learning or algorithmics or, big data processing on things that are associated with users or have data privacy policies associated with their collection and use, there's going to be, and even in the United States, a lot of times per state laws you would have to comply by. So again, it depends on the nature of the data about exactly what you have to consider when thinking about these kind of things. There's a lot of things like processing, batch processing. A lot of these cloud concepts when you think of a cloud native, world, right? There's tons of cloud concepts that are really appropriate for, both time shifting and location shifting. And I know, Asim, you did a lot of work on batch processing. There's the work that has been done both in Google and at Microsoft on Carbon or Kubernetes. Like, how do you build it into the infrastructure so that if you do have appropriate data, you can start to have the data center operating in a carbon aware way. And that's analogous, like in Windows we did on the client and the data center. You have similar concepts, but are more operating on those cloud native workloads, which are very different than what the client workloads are like. So
we focused on a lot on the challenges. We were just surprised by seeing how many people are actually figuring out how to navigate a lot of those. Like maybe they identify, because data can be so difficult to move, maybe they identify 2 data centers that are in different regions and just have local copies of both of those so they can pick when they train. So they're not picking amongst the entire set of data centers, but a specific set. Or like the Windows opportunity, I would have never thought of updates as an opportunity for flexibility, but it's huge, you have up to a week of flexibility, whereas a lot of the conversations we have are we need this job to be done by the morning. We only have 12 hours of flexibility. So the more flexibility you have, the more savings potential you can achieve. So I think we've talked to a lot of creative engineers who have identified opportunities within their very specific software to figure out how to make it cleaner.
And I think that's one of the exciting things about this space is that there's just a lack of knowledge. And this is kind of one of the things I believe for a while is if you pass on this knowledge to people, hopefully some people listening to this podcast now will then have an idea regarding some aspects of their workload or something that they can maybe explore with carbon-aware computing. One of the things that there's always been a lot of interests. One of the things we do in the green software movement is we look at kind of various, various touch points to reduce the emissions of software, and carbon awareness is just one of them. There's always been a lot of interest. The interest comes from the fact that relative to the investment, the return is quite high. This is not going to be the solution, the one solution an organization, adopts to reduce all of their emissions. But relative to the investment you've got to put in, the return is quite high. I think I've seen, there was a paper recently, I'm not too sure how much that adheres to what I've heard from people I know in this space, but it talks about upwards of up to about 30% emissions reductions from workloads. Although I've heard kind of it tops out more about 10%. I don't know how have you guys heard anything about this, about the potential improvements from this space?
I think I can't really reference the Microsoft savings specifically. I don't think they've released that information. I think what you can say is that it's highly dependent on the parameters of your problem you're trying to solve. Like Henry was referencing, in terms of the amount of time frame you have to be able to shift, or the amount of locations you have to choose from for shifting, and what the marginal emissions are in those locations, right? Like shifting from, coal to natural gas might have a certain percentage opportunity. Shifting from coal to 100% renewable like wind or solar is going to have a much different. And if you can completely shift or partially shift, you're going to have a much different. So I think almost every implementation is going to have a different upper bound at what the savings is. And, getting good at measuring that and identifying what that is, I think is, if you were to like break down, if somebody's thinking about building some time shifting or some location shifting, carbon awareness into their application, certainly the number one thing that any user, any developer would need to do is model their potential parameters that they're going to constrain their problem. Come up with some estimates. Like if I can move 5% of my workload within 24 hours in these locations, I have this much potential savings. And then going back to, Asim, your previous point about the potential, like the cost versus benefit, and then modeling the work, like it costs this much development work to be able to do that versus this much savings. And any developer is going to need to do that, like modeling and that estimation before they go forward with an implementation. Because I can certainly think of many problems which might not benefit greatly, especially if they already are very small in the amount of emissions they're generating. And it might not be worth the implementation for that. You might, focus on other things. But there's certainly ones that are, generating a lot of emissions and have the attributes necessary, like the flexibility in time or location, the data dependency stuff we've already discussed. There's certainly problems that could have great benefits in terms of implementation, time shifting. But again, the prereq for all of this is to model that out, understand what that potential is before implementing. And then if I can, I want to talk about one other thing you mentioned, Asim, in terms of the cost versus benefit. I think you're totally right. Like, in other places, Asim, you haven't mentioned it here, but you talk about software sustainability. If you were to like create a classification of software sustainability, and you've done this previously, and I've seen it. And the first branch in that is, making carbon efficient applications. And then the other branch is making carbon aware applications, right? And so those of us who are new to software sustainability might think of carbon efficient applications. In the past, we might have talked about that as performance engineering or improving the efficiency of your algorithms or stuff like that. Almost all of that is really hard. If it was easy, people would have probably have done it already, right? The nice thing about carbon awareness is that it's a different way of thinking about your algorithms that are already running, and it doesn't necessarily require you to re-engineer your algorithms or to change the underlying implementation of your software. You're instead changing the scheduling about how those underlying things work. And yes, I totally agree with you. Like from a cost versus benefit point of view, in a lot of cases, the low-hanging fruit is in carbon awareness in software that I've seen, at least.
To kind of build on that, once you've identified a piece of software that could have flexibility, both spatially or temporally, there kind of tend to be two big factors that drive the potential. One is how variable is the location that you're in. So is there a lot of variability in the emissions rate? And can you take advantage of that with your flexibility? And then comparing across regions, of course. But then the second piece is how capable are you of forecasting that variability? Because then can you take advantage of that variability by scheduling it? So do you have 24, 72-hour, week-long forecasts that you can begin to say, how well does that forecast match what's actually going on? And can I use that forecast to actually think about when to schedule it? So the first step is really saying, what software do I have that can take advantage of flexibility? And then the next section is, once I have that flexibility, is there an opportunity to actually reduce emissions with that flexibility? So you need both of those pieces to be successful.
Yeah, and Henry, so, Watttime provides a forecast. Correct me if I'm wrong. It's up to about 24 hours, right? And
we just extended it to 72, but yes.
Great. And do you have any stats that speak to the accuracy of the forecast over certain periods of time, and what time periods start to be really unpredictable? And is it like correlated with the weather, and is it correlated with a bunch of other stuff that's becomes more unpredictable the further out you look?
Yeah, that's a really interesting question. we've shifted away from an accuracy metric towards an efficacy metric. So if you were to shift based on this signal, this forecast, the signal, how effective are you at reducing emissions?
Okay.
And so if we get the magnitude a little bit wrong, but we get the rank order or the time right, that's much more important than the absolute magnitude. But that's just a training trick that we use on our back end. But it kind of can be represented as accuracy as well. But to answer the deeper question of like, what characteristics do we see? We see that like solar dominated regions tend to be slightly easier to predict because solar is much more reliable when the sun's up, and if you have cloud cover, you'll be reasonably okay. Wind can be much more unpredictable. So wind dominated regions tend to have variability that's hard to detect far ahead. But we might be saying, we think that this hour is likely to have curtailment. We might not know the exact 5-minute period when we're throwing away wind, but generally we can shift load to like the periods that are much more likely to see that high variability or low emissions period.
You just used the word curtailment, and I feel like we need to educate people as to that magic word.
Yes, it's a very jargony, I apologize. But in the industry, we often refer to when we throw away wind and solar because there's an excess of it or there's not enough capacity in the transmission system to move that wind or solar to other places as curtailment. And we're starting to see certain grids throw away wind and solar at kind of pretty prodigious rates. California throws away quite a bit of it in the spring because there's an oversupply of solar because the sun's shining, but high temperatures haven't arrived yet, so we're not running air conditioning. Also in the Great Plains, there can be a lot of wind at night, but low load periods, so there's an excess of wind. I believe even in the Pacific Northwest, occasionally in the spring, without the same low load situation, when there's lots of wind and solar, they'll actually spill hydro over the dams and not generate with it because they have to release it. So you can see how, like, if we can take advantage of these opportunities through load flexibility with software, that's an amazing opportunity. We also talk about devices often too. So smart devices, EVs, that type of thing. Anything that has load flexibility, we're very focused on software in this conversation, but you can see how it could be other things as well.
Right. And again, I think I was thinking about that very concept, Henry, in terms of, if you have to think about software in a very broad sense when you talk about the total opportunity here. If we're only talking about PC software, the total opportunity is, going to be limited by the number of PCs in the world, as, Windows devices, Mac devices, and throw in, obviously, the mobile devices in the world, which kind of sip power. But, we all need to think about the broader definition of software. It's software running in our thermostats, even though it's driving, both, energy if you're on, electric heat or electric heat pumps and stuff like that, or natural gas use, which doesn't have the same benefit of the time shifting. But it's software that's running like, my robot vacuum cleaner that's sitting right here. It's software that's running, almost everything in our future homes and businesses are being controlled by software and have differing abilities to take advantage of the topics of, carbon awareness that we're talking about, right? And so, the IoT space is huge relative to the PC space that when we typically think about when we think about software, or the cloud space when we think about software. But those are all software developers, and they all, in a lot of sense, have connected internet connections and can take advantage of some of these signals. And, I think another area that, we talked about, I don't have the ability to talk about too much, but we need to think about how does this take advantage of disconnected environments? Not every phone is connected at all times to the internet. And can you still do carbon awareness when you're disconnected? I think there's a lot of work to be done there. Is it a huge impact or not? I don't know. But some of the modeling and stuff like that, it has seasonal variability as well, which might be able to be built in as a baseline if you don't have, rich live internet connections on at all times.
We've had some conversations with our partners, like what about fallback schedules or defaults that still do some scheduling that can maybe not perfectly identify that variability, but can still take advantage of some of the grid emissions variability. And we've also had conversations around like, how frequently should that device be connecting to to the kind of grid emission signal and making decisions based on it, because that has a carbon penalty to it as well. Because every time you reach out, run the computation to decide when to schedule load, there's a carbon cost to that. And you have to make sure that the flexibility is achieving savings greater than the cost.
Yeah, we ran into on another feature. I won't name the feature, but we did investigate a machine learning, approach to reducing, amount of power used in Windows. It turned out in that case, the amount of processing and power used for the processing to run the algorithm was greater than the potential savings for it. So yeah, you're essentially at a really great point. And then that goes back to the other point I was trying to make in terms of you got to model all of this. But yeah, Henry, you totally got to model the new stuff you're writing as well to make sure you're not, stripping out all the potential savings by the new code you're going to start running here. And hopefully you're looking at loads that are large enough that, the amount of algorithmics and connections and services you need to write to do time awareness is probably going to be much, much smaller for an appropriate workload that you're looking at. But again, that's where the modeling and the measurement is super important to begin with.
And we've seen people scale that level. Like if it's a small workload, they'll just pull the forecast once, make a decision, and then not check it. Or they can even do it every 3 hours instead of every 15 minutes or something like that. So there's lots of ways of adjusting the workload to the job.
One thing I wanted to cover, I think it's quite interesting to also cover the future, because one of the things I think, Henry, you've mentioned to me, and I think is quite important, is that everything that we're doing today, like if you talk about modeling something today, that's today's impact. Yet the world is actually, when we're moving towards a future where more and more of the energy is coming from renewables, and therefore the impacts, if you were to build something today with your carbon aware workload, it has an impact of 10%, in 5 years' time, it might have an impact of 20% because the world's becoming kind of a lot more variable. I mean, do you have any estimates of how that's going to go in the future?
We definitely are seeing an acceleration of renewable deployment, which is increasing the variability of grids. I mean, historically, the electric utilities, balancing authorities, grid operators have always matched generation to demand. And I think we're shifting into a paradigm where we're going to have to be matching more of the demand to the variable generation coming from wind and solar. And so as that variability increases, we're just seeing kind of dramatic increases in curtailment and renewable deployment that enable just much greater savings. You're kind of shifting from a world where you're occasionally trying to pick up that excess renewables to a world where you're trying to avoid the peaking fossil plants, which is just a much greater opportunity from an emission savings span, where you just move a load as far away from the peaks instead of trying to find those troughs.
Can we just dig into that for a second? Because I think that's quite interesting, because that's almost the opposite of curtailment. Because are you talking about peaker plants there? So
exactly. So you could have 100% renewable all the time, except for occasional periods where they have to turn on those really dirty peaker plants, whether they're fossil oil, fossil gas, or fossil coal. And so you just want to avoid those periods at all costs. Instead of right now, we're seeing occasional periods where we're throwing away renewables, and you want to move as much load into those. So it's kind of like this expansion of opportunity, which is really interesting.
Because my understanding of those peaker plants is, the grids need the capability to deliver energy very, very, very fast. And they tend to be natural gas, don't they? Or some sort of gas, because you can just burn that quickly. Interrupted workloads, I think, is what it is. It's interrupting. So not running something for 5 minutes could be as valuable as shifting your workload to another hour because you're avoiding the worst emissions.
Absolutely. And of course, you want longer periods. The more flexibility you have, the greater that opportunity. So there could be a 2-hour period in the afternoon where they have to bring those peakers on. And if you can avoid that, that can be really helpful.
But talking of this variability, one question that comes up pretty frequently is the nature of different grids and the makeup. And especially when it comes to grids that are more towards the grids we're going to need, say, 30 years from now, which a lot of times, has the peak, and Henry, you're more of an expert on this, so correct me if I'm wrong. The peak loads are going to be handled by, in some of these grids, nuclear, I think long-term ideally in some cases. And then the base load is going to be, renewables for the most part. And so in those grids, when I think of a couple regions today that we deal with, Iceland, typically we treat it mostly 100% renewables. France is another one because it has high investment in nuclear. We kind of treat that as 100%, zero carbon region. And again, Henry, you have to correct me if I'm wrong on those two regions, but it's because they have this nuclear renewable, not the nuclear in Iceland, but in France, high amounts of renewable. And in that case, the carbon awareness is just kind of a flat, clean signal. And so as the grid evolves to these things that are like zero carbon grids, like the techniques we're talking about, they don't have as much impact, right?
So this is a really interesting disconnect that we're seeing. Right now, and especially in the near future, load flexibility will have a lot of emission savings potential because it'll be able to shift out of those dirty periods into the curtailment periods. But once we eventually attain those 100% or near 100% clean grids, the flexibility won't be saving emissions directly, but it will be enabling 100% clean grid because you'll be following wind and solar. And if we didn't have that flexibility, we would have to be fossil resources. So it's an essential piece of a clean future grid, but it's going to be harder to quantify the benefit of it in that future.
That's a great way of putting it, Henry. It's we get to clean grids faster the more we have carbon awareness, because carbon awareness allows us to maximize the use of our renewables, whereas today we're already curtailing them, right? I think that's an excellent way of putting that.
Exactly. And so it's like a critical piece of that future grid. Without it, we wouldn't be able to attain it as quickly, as efficiently, as cheaply.
It makes me realize that I had an epiphany moment a year or so ago when I realized the way, this isn't just in computing, but just generally the way we consume electricity is based upon the way the energy grid was created. Like a lot of other things we do in our life, we flex based off of what's going outside in the world. Like I don't try and grow plants in winter in my garden because it's cold, right? So we normally have this thing where we flex and we change what we do based off of the natural cycles of the earth. But because we've just had this thing called coal, which you could just burn whenever we wanted, we've not had to have that pressure in the rest of our world. And what renewables is bringing into the world right now is like, well, look, you can actually do. I actually find it quite beautiful because oftentimes we're really disconnected from nature. And one way I think about carbon awareness is actually I'm building software which responds to natural cycles of the earth, and it connects me with nature in a kind of abstract, an indirect way, but it's one of the few ways you can connect with nature, I think, in software.
It's a really interesting point about the electric grid in that it's very unique in the sense that it needs to be balanced instantaneously at all times. There's no flexibility in terms of timing. So if there's a demand on the electric grid, that has to be met immediately. You can grow rice and store it in a silo or in a grain elevator for a while and then release it. The electric grid has to be instantaneous. And until we have a lot more storage or pumped hydro, we're not going to have that flexibility. And so demand has to kind of follow supply much more closely.
I think it was in California, right, where they're starting to look at in terms of increasing storage by starting to enable all the growing amounts of EVs in the world and connecting those batteries and utilizing them as a bunch of local storage. So we have this future that's way more complex in the sense that, we're drastically increasing the amount of storage. Sometimes it's centralized storage. Sometimes it's this municipal storage that's your EV, and it's just can be a local buffer, not only for your house, but also for your driving. And you could charge that in a carbon aware way. And then, we're adding municipal solar, we're adding, utility solar, we're adding all this. And I think, the grid gets way more complex, but like you're saying, Asim, I think it also, you get these new patterns, these new natural patterns that start to arise out of it. Yeah, the technology is going to play a really key role in all of this, how to implement it.
I'll toss another bit of jargon in here. V2G, vehicle to grid. So there's both smart charging of your vehicle, but there's also, can that vehicle actually push power back to the grid at important periods? It's all software driven, even though it's living on hardware. One other question for you, Asim, because I think we're approaching the end here, which is one of the things that we're excited about this is that it puts the capabilities in the hands of developers to actually affect this. This is something that a developer can make a decision about, actually make affect the software that they're working on and have a real emissions effect. Is that something that you've explored with people?
Are you talking about some of the projects that are working in the foundation? Because we have one particular project, which is the Carbon Aware SDK, the software development kit, which is, a lot of what we're describing here. I mean, the logic is the same. Every single company that wants to implement carbon awareness is pretty much just creating the same logic. And so one of our projects is create the Carbon Aware software development kit, which is going to enable developers to much more easily implement some of this logic and functionality. And I remember when I was having conversations with that team, kind of the same thing came up, which is like, we started this with this idea that we're going to reduce the carbon emissions of software. But actually, software drives everything. So this SDK could be used for, I have an EV in my driveway, so I could build something to leverage it and charge my EV based off of, some sort of signal or heating my house or something like that. Because I think that's one of the things we're seeing is if we can just make it easier for people to do this, then they're more likely to implement a lot of these things. And I'm seeing it implemented in other places as well. There's lots of websites that and I love the impact might not be so great in terms of carbon savings, but the impact's quite high in terms of making people aware of what the potential is. There's a really great magazine called Branch Magazine from one of our colleagues here, Chris Adams. And it's an online web magazine which changes its behavior based off of electricity grid signals. And so the images will disappear if it's high carbon intensity, and it'll replace it with text and words. And that's really good because everybody reading that is suddenly then aware of this entire concept because people aren't aware of it in the first place.
One of the pieces that I think I really like about it too is that a lot of this is being driven by the developers themselves, not necessarily the sustainability team, like the corporate sustainability team at these organizations. They're like, the developers see an opportunity, they understand how the code works and can actually make a decision about how to drive emissions reductions.
I 100% agree with you. And I mean, some of that is natural in the sense that the sustainability stuff in most corporations are driven a lot of times through the supply chain organizations. And a lot of times that's because the measured CO2 impacts the majority of it sometimes coming from the supply chain. But I think the opportunity in terms of cost versus benefit on the software side, I think it's an area where we can change faster and have some initial impacts greater than some of the supply chain changes, which are longer term kind of things. And to be clear, all of those, both sides of the thing are totally interleaved. There's not a fine line between them.
So I think that's all we've got time for today. So it was a really wonderful conversation with everyone. Just a final thought for me. I just want to give a shout out to an event that's happening in the middle of June. So the foundation has a global summit, which is being run in over 20 locations around the world. If you want to meet other like-minded people like us, kind of thinking and talking about these topics, come find us. Come find your local event at summit.greensoftware.foundation.
I think the final thought is that, having gone and tried to build carbon aware software, it was, as long as you're making sure that you have the ability to measure and that you are actually doing the engineering that is going to have an impact, it's actually super motivating to look at. And it's actually, the technology it's a rich area of technology. And it may seem intimidating when we add these new kind of terms about how the grid operates and have to think about yet another thing in software. But it's really, once you get in there, the concepts are pretty straightforward, and adjusting your software to do this kind of stuff is actually not too hard. So I'd encourage folks to try it out at least.
And I think one of the things we're excited about is people are coming up with use cases that we never thought about. So scheduling Windows updates, like we hadn't even considered that as a possibility. So people come up with very creative ideas, both region shifting, location shifting that we would never have thought of. And so we're always excited to see the kind of expanding possibilities for load flexibility.
Thanks for listening to Environment Variables. All the resources for this podcast, including links to our guests and more about carbon-aware computing, as well as the Green Software Foundation, are in the show description below. We hope you enjoyed the show and see you on the next one. Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show, and of course, we want more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. Thanks again, and see you in the next episode.